Good evening, everyone. I'll start the class in a minute. Okay, tiny recap of whatever we did in the past few lectures. We had done quite a lot of questions of combinatorics, and this question I think you might remember. This also appeared in IOQM this year. Very similar to this. Today we'll do a little bit of ratio proportion related questions and new concept. Lecture 5. Okay, let's start with the first question. Okay, question might seem quite lengthy, but you need to pick out the key information from each of these, from each statement. While checking for broken calculators, Ravi finds that there are two calculators that are found to be broken when 12 calculators, each from 64 crates containing 144 calculators, were tested. So there are 64 crates which contain 144 calculators each. And of those 144 calculators, 12 of them were checked, and in total, two calculators were found to be broken. If there are total 128 crates, then you need to find or estimate the total number of calculators that were broken, that could have been broken. In reality, the answer could be like all the other calculators that are not checked are all broken, but we are assuming that everything is uniformly sampled. So try to think what the answer would be. Pranjal, not correct. Try again. So each crate contains 144 calculators. Okay.
And what do you mean, sir? 12 calculators each.
So from each of the crates, 12 calculators were removed. And then in the end, it was found that of the total calculators that are tested, only two of them were broken. Pranjal, correct. Pranshu, try again. Harshit, try again. Pushkal, try again. Okay, so I think some of you are like missing the key idea here. Answer is not 3072, which is I
Sir, please
think
explain the
48 times
difference.
64. I'll explain. So there is a total, this is the total 128 crates. Okay, out of which we go and we check 64 crates only. Okay, and this is one crate. This contains 144 calculators. Out of which we take this tiny portion, which is 12 calculators. So if you can calculate, there are two ways to go about solving this question. Uh, I won't mention either of them. This is the situation at present. This is the total number of crates, out of which 64 are chosen. Of those 64, there are 144 calculators in each crate. 12 of them are chosen at random. And then total, out of the total tested calculators, two are uh, found to be broken. So you have to find the total number of calculators that could have been broken among 128 crates.
So is my answer correct?
Adya, not correct. Sumit, not correct. Saurabh, not correct. It is not 2 out of 12 that are broken, okay? Of all the total calculators that are tested, only 2 are found to be broken. You see, that good of a manufacturing company that is. Saurabh, correct. Ideally, it should be 0, correct? You don't want broken calculators when you go and
Sir,
buy.
is my answer is correct.
Saurabh, yeah, correct. So, there is two ways to go about doing this question. One is like you figure out what are the total number of calculators. Method 1. Total calculators tested. This quantity is easily you can find it. It is 64, the total number of crates, out of which 12 calculators from each crate are tested. This is the total calculators that are tested. Out of this, 2 are broken. So we can say that 2 out of 64 times 12 calculators on average are broken. This is the ratio in which you have broken calculators to total calculators. And if you have a large enough sample size, then it is like a random selection is a good enough estimate of the total proportion. Okay, this is how they do QC past in most situations. They don't check each and every item when it is when like it is allowed. Okay, you don't need to check each item, and the chance that each item actually turns out to be broken is very, very small. So in that situation, you just go and check few items. It turns out that this is the ratio in which calculators are found to be broken. So this might be the total ratio of the total population. So total calculators will be equal to, there are 128 crates, out of which there are 144 calculators in each crate. This is the total number of calculators. So actual broken, again it's an estimate, will be total calculators times 2 by 64 times 12. And if you calculate this, answer is equal to 128 times 144 times 2 upon 64 times 12. This becomes 12, 2, and then you get 48. Okay, this was the first method. The second method is also very close to the first method only. So method 2 is a fraction of calculators tested. What are the fraction of calculators tested? Out of the total population, you have 64 by 128. These are the fraction of crates that are tested. Out of which, from each crate, you are testing only 12 by 144. These many calculators are being tested. You just invert this and multiply by uh, how many ever samples you found to be broken, which is 2. You can directly get, this will become 2, 12. You have to supposed to get the same answer only. 4, 8, 48 will be the answer. It's your job to think about why you can take the fraction of calculators that are tested, and out of which actual number of calculators that are found in the calculator which are found to be broken. How, if you multiply with the inverse, you get the correct answer. Think about it. It's the same thing as the first one. Okay. This type of logic is called population estimation. I'll give one more question along the same lines. Question 2. A zoo has n lions. You need to find n. Okay. It is given on day 1, 1000 lions are marked with uh, UV with an invisible ink. Okay, in a non-invasive manner, invisible ink, visible under UV light. Okay, on day 2, 200 lions are selected. Not from the 1000 lions that are marked. Okay, from the total population, you are selecting now 200 other lions. Not other, I mean, it's a random sample. Okay, 200 lions are selected, and it was found that 5 of the lions have ink painted on them. Of course, when checked under UV light, because it's not visible to the naked eyes if you are painting with invisible ink. Uh, I'll repeat the key figures. There are n lions, 1000 lions are selected, and they all are marked with
Sir,
invisible ink.
can the
After that,
answer be very, very big?
Answer is going to be big. This like type of method is used to figure out
Sir, is now
population
correct?
for very big
Is now
quantities. Sumit and Pranjal, correct. Yeah, find it.
Sir, please explain the question.
Uh, अच्छा, one of you is asking me to explain in Hindi. So, how many of you actually want Hindi only? So, there are 31 of you, so you can unmute and ask uh, if you have any doubts. ठीक है, हिंदी में भी समझा देता हूँ. टोटल n लायंस है एक जू में. पहले दिन पे जाके 1000 लायंस को उठा के वी मार्क देम विथ यूवी लाइट. ठीक है. ये क्यों कर रहे हैं? क्योंकि हमको टोटल एन फाइंड काउंट करने लायक टाइम नहीं है, बट 1000 लाइंस को पकड़ के उनको ऊपर एक बस एक मार्क लगाना है, उतना टाइम है. तो उतना करने के बाद सेकेंड डे पे और कम काम, लाइक 200 लाइंस को पकड़ के उन पे चेक कर रहे हैं कि हर हर किसी पे कि है वो इंक या नहीं. नाउ यू हैव टू फिगर के ये दो नंबर्स एंड ये पांचवा टोटल नंबर ऑफ लाइंस जो हैव द इंक ऑन देम ऑन डे 2, जब एक रैंडम सैंपल ऑफ 200 को सिलेक्ट कर रहे हैं. तो यू हैव टू फाइंड है कितना हो. ठीक है. Think about it, it's the same concept as the previous question. Tuba correct answer, Manas correct.
Sir, does you complete theory part of ratio proportion?
No, I'm not doing theory or anything. I'm just doing some interesting problems and uh, some case studies. That's it. We don't have enough time to go over all the theory, anyways. Mariam correct, Pranshu correct, Khushali not correct, Om correct, Pranshu correct.
Sir, in the previous question, method 2,
Hmm.
why did you do like 12 by 44 or by 144?
Because see, it was given that you have total 128 crates, so half of them you are testing. From the half of out of the half of them, for each crate you are just checking 12 calculators out of 144 packed inside the crate. So you
Okay.
don't want to go over the entire load of removing each calculator and checking. So you are checking only 1/12 of it.
So you
So
basically did like total number you're testing
yeah,
into 2.
yeah.
Got
So
it.
basically 2 will be equal to the fraction of population tested actually wrong, actually uh,
Incorrect, like not working.
not working calculator. So that
Yeah,
fraction, that proportion will remain same.
yeah.
Abhyuday, correct answer. Akshita, not
Sir,
correct.
from where we complete the theory part?
Theory part, there are good books that are available. I'll mention it during next class. I don't have any particular book in mind at the moment. Okay. So here, what is happening is, of the total population, fraction, you can calculate fraction of lions marked on day 1. Okay. So what you do is, you have 1,000 lions that you mark on day 1 out of total n number of lions that are there. This has to be equal to fraction of lions with marks spotted on. Again, these are approximations which in the large population limit seem to be equal. This is usually confusing because this is not a proper equality. Uh, this is approximate only. So it is, that's why it's called estimation. We are not doing questions that are certain, like the next question which we'll do, which will be more certain. You have 1,000. This is equal to 5 over 200. Because out of the 200 lions that are actually brought in, 5 of them are ones which have the mark on them. So we have 1,000 by n. is equal to 5 by 200. If you calculate, you find that n is equal to 40,000. And you can see very clearly, na, ke 40,000 lions, you don't know the actual number, you know it's a very large number. That's why if you know approximately how many there are, you can actually decide up these two numbers, 1,000 and 200. This I'm talking from like experimental perspective. Uh, why 1,000 is larger than 200, that also you can think that this is not maths related, but why should you keep 1,000 greater than 200 in this situation? That is also an interesting idea to explore. Okay, try the next question.
Sir,
Yeah,
how could you means uh, how could you equalize the two fractions?
it is because this is again, this is some theory that is not uh, built on any proofs in mathematics. It is empirical evidence. Okay, if you have a large population, it's like you take a little bit of salt and put it in water, and you take pour it into a tiny glass. The amount of the fraction of water in that big jar of water, fraction of salt in it, compared to the fraction of salt in your small glass, that fraction will remain constant. Na? That much you agree? Okay, if you make lemon juice and pour it to everyone, everyone will taste the same concentration of lemon juice. No one will be like, okay, I have too much, I am tasting too much lemon. Someone will say, okay, it's all fika pani. That won't happen, right? So when the number of such samples become large enough, you can do this equality. This although doesn't exist for smaller number of samples. For large samples, this is very much true. Okay, again, this is approximate only. And questions like this expect you to assume equality. Okay, that's all.
So I didn't understand how you got 40,000.
Oh, you multiply 200. So you take n over here, 200 times 1,000. So 200,000 divided by 5 is 40,000. Just solve this equation. Okay, two jars contain same number of marbles. In jar 1, okay, so ratio of blue to green marbles in each of the jars is 9 is to 1 and 8 is to 1 respectively. Okay. If so, in the first jar, there are 9 blue marbles, and one for every 9 blue marble, there is one green marble. In the second jar, for every 8 blue marble, there is one green marble. And the total number of marbles in both the jars are same. If you are given that number of green, total number of marbles is 95, find number of uh, blue marbles in jar 1. Find difference of number of blue marbles in both jars. One sec. Okay. So you can come up with variables for each quantity. Try to reduce the number of variables and find the difference. Amishu, not correct. Try again. Akshita, correct.
Sir, it is 95 in each jar or both.
No, in both put together are 95. Pranjal correct, Tuba correct. Okay, so far only the ones who I have said I have answered correct. Pranshu not correct, Harshit not correct, user not correct. Abhyuday not correct.
Sir, can you check my answer?
Abhyuday correct, Manas correct, Kavya try again. Rehan try again. So here 95 is the total number of green marbles in both jars put together. Okay. Sumit try again. Saurabh try again. This point I think I should give a hint. Assume there are 9x blue and x green marbles. In jar 1. Do similar for jar 2. Pranshu correct. Okay, anyone wants me to wait some more? Nis try again. Okay, I'll wait for 2 more minutes. Okay, keeping this question aside, I'll give one more bonus question that I will answer in the next class. Uh, 10 people are playing bingo. Okay. Each person has one card with 10 numbers written on it. This game is Okay. Then, if you have understood the question so far, 10 people are playing a game of bingo. Each person has one card and with 10 numbers written on it. This game is being played with 10 numbers only. This is a special kind of bingo where if one particular number on your card is called out. Actually, wait, I'll reword the question. I'll give the question after completing discussion of question 3. Fine. First, I'll complete the discussion of question 3. Yeah, okay. I'll start with discussing this question. If you assume that there are 9x blue and x green marbles in jar 1, and for jar 2, you can do the same thing. So you have jar 1, jar 2. Out of these, you make green and blue differentiations. There are x green in this, there are 9x blue in this, there will be y green in this, and 8y blue in them. Another information given is that uh, two jars contain same number of marbles, which means this and this amount put together, we have 10x equal to 9y. This is equation 1. Second equation that you have is total number of green marbles is 95, which you can also write down. So x plus y is equal to 95. Now using the first equation, I can write it very neatly in terms of another variable, which is the idea usually used in ratio and proportion. You have 10x equal to 9y, you can write x upon 9 is equal to y upon 10. And you can say that this is equal to some other variable k. Now, instead of working with these two variables, which are, if you substitute into each other, the very much a lot of fractions will form, and then there is possibility of doing some error. Instead, you just write it equal to some value k and then find the value of k. After finding k, it's a very direct homogeneous equation between y and k and x and k to get the value of x and y. Adya, correct answer. Sumit, not correct. Try again. So, Sumit, you have to actually find the difference between the number of blue marbles in both jars. Okay, so jar 1 might have some amount of blue. Basically, you want difference of these two quantities. Okay, so if I take this, I get x equal to 9k and y equal to 10k. 9k and 10k, when you add, I get 95. So 9x plus y, Sumit, correct, is 9k plus 10k, which is equal to 19k, and that is equal to 95 from equation 2. So we find that k equal to 5, and this way we get answer equal to 9x minus 8y. Actually, the mod, I don't know which one will be larger and which one will be smaller. Is equal to 9 times x is equal to 9k minus 8 times 10k. Thankfully, this is positive as it is. And that becomes 81k minus 80k, which is equal to k, and that is 5. There might be other methods to solve this, but for now you can rely on this. If anything you want to take away from this question, it is this. You can convert this particular equation into another variable k, solve it in terms of that. It's slightly faster if you get the hang of it. Okay, try this one easy question. A jar of marbles has two ways to classify them. Okay. Size, according to size, we have 20% small, 40% medium, and 40% large. And then you have color. Based on color, you have 30% red, 20% blue, 40% green, and remaining 10% yellow. Find, okay, one more thing is here. If half of the large yellow and small green were broken, find fraction of broken marbles. Saurabh, changing the time would be unfeasible on my end and TLUPS, so can't help with that. Much of the information given here is useless. You just have to cherry pick the useful information and get the answer. You can either find fraction or percent. Akshita, correct answer.
Also, I couldn't hear you.
Correct answer. Hmm. Pranjal, correct. Okay, in case some of you are new to this class, I will first give you the lecture notes that has been discussed so far. You can check the meeting chat.
Sir, is my answer correct?
Just a second. Manas not correct. Harshit not correct. Try again. Tuba correct answer. Manas correct. Okay, if you're done with this question, I will go ahead with the bingo question.
Sumit,
Hmm. Sumit, correct. Raina correct. We'll discuss the answer in some time. Harshit, try again. In a game of bingo, each card has 10 numbers. 1 to 10. Only numbers 1 to 10 are called each in each turn. Keep the question visible so that you can keep working on fourth question. Yeah, I have the question in mind, but I'm not able to formulate it in bingo terms. I'll keep the question in the document. You can all save the link which I've shared it on the meeting chat. After 8 p.m. I put the question inside here. They are not correct. Try again. Harshit, try again. Sumit, correct.
Sir, I sent the answer much earlier and you also put correct. I haven't sent it away.
I mean, that answer is correct. Adya, try again. Not
So
correct.
won't be able to see the bonus question, no?
Bonus question, I need to formulate it. I have the structure of that question in my head, but I'm not able to write it down in terms of that bingo terms. Uh, I'll send it after 8 p.m. You can open up the link later on in the evening and check it. Okay, so here you have to understand that of the all the sizes, these are independent. Size and color are independent without actually considering these two as independent. These two ways to classify the marbles as being independent. This question is not able to cannot be solved. Okay, Abhyuday, correct answer. So if you have a certain number among all the red marbles, 20% of the red marbles are small, 40% are medium, and 40% are large. This you have to assume. It's or the size and color are independent, is what I'm saying. So if you consider that of all the entire marbles, if I say 30% are red, 20% are blue, 40 green, okay, 20, 30, and somehow this is 10%, 10% yellow. Among these also, I can say that 20%, 40%, and 40% each will be small, medium, and large. And large. In the end, you are being asked to find large yellow and small green, is it? These two regions of the rectangle, effectively you are being asked the ratio of these two regions, and then you have to half them because only half of them are broken. So that way you get the total number of broken marbles. So percentage of yellow
Sir, show the question mark.
large. Percentage of yellow large marbles will be, you take the percentage of yellow and the percentage of being large. These two fractional quantities, you multiply them, you will get the total number of yellow and large marbles. Because think about it, if you want the area of this tiny rectangle, relate it to the area of rectangles over here. Area of this rectangle is this side length multiplied by this side length. And the area of this entire rectangle is both side lengths. If this is 10% of the length and this is 40% of the breadth, the total area ratio will also be the product of the percentages, which will be 10% times 40%. And then you have percentage of green small marbles. This will be because of being green, it will be 40% multiplied by 20% for being small. Now remember, this multiplication of percentages is not like direct multiplication. That percent symbol carries with it a 1/100. So you have to keep that in mind while solving it. So this is 10 by 100 times 40 by 100. And this is 40 by 100 times 20 by 100. Cancel some zeros. And you'll find that total broken is equal to half of whatever this fraction is, 4 by 100 plus 8 by 100. So you get that this is 6 by 100. 6 by 100 can be written as 6%. So you can always replace 1 upon 100 with the percentage symbol, and you get the final answer also. This is a fraction, this is a percentage. Both are equivalent quantities. If you are asked, if you have been asked percent, then this is the answer. Uh, Akshita, you can unmute and ask your question. I can't understand.
So like, can't there be a case in which there is any color and it doesn't has any particular size, like any of the things?
If they are saying mentioning like that, that means that you don't care about the size. So instead of multiplying by a percentage placeholder for the size, you can just multiply by 1 or 100%. Multiplying by 100% is equivalent to doing nothing, because you are not considering any cases of that size. Okay, so if you are said कि only blue marbles you want to consider, all the blue marbles, that would be this entire range. Okay, another very, very simple question coming your way. Question 5. If angles of a triangle are 3:3:4, find largest angle. Okay, very good. This though I hope everyone answers quickly and fast.
Shall I sometimes?
Manas, Sumit, Akshita, correct answer. Abhyuday, correct answer.
Sir, is my answer.
Pushkal, Harshit, correct. Saurabh, correct.
That's the
So,
previous answer. Previous answer.
okay, they are correct. Yeah, Mehak, do one thing. You can, I'll copy your question, whatever you're sending. If I get the answer to it, I'll write it in the chat over here. I write it in the PDF over here. Okay, everyone has given correct answer. No one has given wrong answer. So very good. What if the question? Okay, never mind. I was going to say what if the question was in radians? What would be the answer? But that is also very easy to calculate. If you want to find the largest angle, you know that A is to B is to C is given as 3:3:4. Again, this can also be written as A upon 3 equal to B upon 3 equal to C upon 4. You can assume this is equal to some quantity X. A plus B plus C, these are the angles of a triangle. If A plus B plus C is asked, that is 180 degrees because of angle sum property. When we do geometry, we'll talk about proofs for this. A plus B plus C is 180. So you can write 3x plus 3x plus 4x equal to 180. Now, from this, you have 10x equal to 180 and x equal to 18. 4x being the larger side, that will be 72. Okay, try question 6. If 15% of x is 20% of y, how much percent of x is y? Akshita, correct answer.
Sir, I'm pretty sure my answer is wrong, but can you check it?
No, no, it's correct. Manas correct. How are you 100% sure that it is wrong? But it doesn't that make your assumption also, I mean, your ability to solve questions uh, lower if the correct answer you feel is wrong. Mariam, correct. Abhyuday, correct. Tuba, correct. Pushkal, correct. Adya, correct. Saurabh, correct. Sumit, correct. Amishu, correct.
Sir, my
Who is asking? Saurabh, I think your answer. So if you are asking correct, Pushkal, Saurabh, correct.
sir, my answer is 75.
So, that's correct. But yeah, I mentioned it's correct. Okay, answer over here is 75. The way to solve this question is first figure out what you want, and from there you can actually start to get that particular stuff that you want. How much percentage of x is y? This question is asking y equal to f% of x. Okay, this is the equation that you want to solve. Instead of f, let's call it p%. In maths, of means multiplication and percent means 1 upon 100. So like it's the equations but written in word form to convert this into maths so that you can do maths properly. You have y is equal to p by 100 times x. Okay, of implies this. I know this is basic stuff, but first class for ratio proportion algebra will be basic one. Om not correct. Atrij, Arij not correct. Arij correct answer. Sorry. So this is the equation. You
Sir, I
want to
am
find p. What happened?
Atrij, Atrij.
Atrij, sorry, huh? Atrij. This is to find. You have to find p.
Sir, why to introduce a new variable p?
I mean, p is the answer, na. So
Sir,
it's
but
like
no
answer
need
is
now.
already.
So we can find y in terms of x and then calculate.
Yeah, you can directly do that ratio and get the answer, but fine. There is chances that you mess up what you are supposed to do. Are you supposed to divide x upon y or y upon x? This can be confusing, na. Because I think that's why Pranjal was saying कि he is 100% sure or like pretty sure he is wrong. Because the question can be confusing that way. Next, you have to look at the first question. If 15% of x is 20% of y, that means it's equality. You have 15% of x is 20% of y. This can be interpreted as 15 by 100 times x equal to 20 by 100 times y. 100 get cancelled. You can cancel 5 on both sides. You're left with 3x equal to 4y. So 3 upon 4 is equal to x upon y, which is equal to p upon 100. From here, you get p equal to 70. Okay, so some of you are still getting the answer wrong. So it's mainly to uh, like go over these mistakes so that they don't happen in the actual exam. Question 7. W is to x equal to 4 is to 3. Y is to z equal to 3 is to 2. Z is to x equal to 1 is to 6. Z to x is 1 is to 6. Find W is to y. Nikshita, correct.
Can you please repeat?
Correct, correct. Answer is correct. Manas, correct. So this question I'll not do it the entire way. I'll give 1 more minute and then I'll answer it. Kushali, not correct. See, if you directly multiply all of these, that won't give you the answer. Amishu, not correct. Harshit, not correct.
Answer correct.
Pranjal, not correct. Tuba, not correct. Pushkal, correct answer. Atrich, not correct. Abhyuday, correct answer. Okay. There is one way to go about doing this. That is, you can
I
write
think
all
that's
of
the
them in
double
terms
check.
of.
Can you now check?
Pranjal, correct. The way to go about doing this is either you can convert everything into fractions and then try to figure out a way to eliminate x
Sir, is my
and
answer is that
z. Saurabh, not correct. Try. You have to find a way to eliminate x and z. So you have w upon x is equal to 4 by 3. You have y upon z is equal to 3 by 2. And you have z upon x equal to 1 by 6. So if you want to, if you can see that w is to y. This is equivalent to solving to w upon y. Correct. So just figure out w upon y from here. We can take we can divide these two quantities. Since we have already converted them into fractions, from here, if we divide both of them, we can see that w upon x times z upon y is equal to 4 upon 3 times 2 upon 3. So the denominator of your denominator will become your numerator. Numerator of your denominator will remain the denominator. Okay, these fractions I'm dividing, or I'm multiplying the inverse of y upon z to w upon x. This way, I get w upon y times z upon x is equal to 8 upon 9. This is something that few of you have answered, which is wrong. Adya, correct. Om, correct. Mariam, not correct. To remove z upon x, you can divide by this quantity over here. If you divide by 1 upon 16, w upon y equal to 6 times 8 by 9, which is 2. This is equal to 16 by, which is the answer.
sir from where you take six?
Huh? These are old AMC questions.
Sir,
You can
from
find them.
where you take
You can find
six?
all of these questions on AOPS website. Art of Problem Solving. Of course, I mean, they won't be categorized into ratio and proportion type questions and something. If you search AMC8, you will find all past year questions of AMC8. And
So
Sir,
I
from where
answer
you
is
take
4.
six?
from where I got 6, z upon x is 1 upon 6. Now, so if I multiply x upon z, that is the same as multiplying by 6, because from here x upon z is equal to 6. Correct.
Sir, why multiply reciprocal?
Because see, in the end, I want w upon y, correct? If x upon the entire, if algebraically you are seeing, I am trying to eliminate x and z to get w and y only. In the end, I will be left with either w upon y or y upon w. And
Okay,
you
sir.
get the answer from it. Another way
So,
to actually do this is, one second, from here, if you want to just remove x, x, z and z, you can see that z and z are like opposite placed, whereas x and x are like placed one on top of each other. It is easy to just multiply all of these and do this. In red, I'll just in short, very fast, write what I'm trying to do. 3 times 1 is 2. 4 times 2 times 6. And what I get is 9 is 2. Whatever this quantity is, should be 48.
So 48.
And yeah, even before doing this, you can like divide by 3 on both sides, and you get 3 is to 16. And 3 is to 16 is for y is to w, but you want w is to y. So answer will become 16 is to 3 for this. Those who understood that method might have used it already, but you don't need to go through the entire method of solving to get the answer, is what I'm saying.
so I got 4 is to 3 by 4.
4 is to 3 by 4 is correct. So you bring that 3 up. 4 is to 3 by 4 is correct. Yeah, you get 16 is to
So it
3.
becomes 16 is to 3 by 4. Like,
Yeah.
why do we take the denominator 4?
So no, you got 4 is to 3 by 4, correct? So enemy of
Yeah.
your enemy is your friend, correct? So a quantity that is reducing the denominator is actually increasing your actual number, correct? So you can remove that 4 and put it in the numerator. That is how you get the answer.
Okay. Got it. Thank you. Thank you.
So I'll end the meeting. I need to go somewhere else also. We'll have our next class in 2 weeks. See you later. I have updated the link, so you can access it through the chat. So you can take the link from the chat. I'll post it again. Okay. Bye guys.